In this video, we are going to learn about formal charges. By the end of this video, you should be able to compute formal charges for atoms in any Lewis structure and use formal charges to identify the most reasonable Lewis structure for a given molecule. Formal charge is the hypothetical charge the atom would have if we could redistribute the electrons in the bonds evenly between the atoms sharing them. Your textbook gives the formula for formal charge as formal charge is equal to the number of valence electrons for the atom minus the number of lone pair electrons minus 1/2 the number of bonding electrons. Now, that equation is perfectly fine. I like to reword it a little bit when I think of it. I just find it a little bit easier. Formal charge is the number of valence electrons minus the number of non-bonding electrons, which is the same thing as the number of lone pair electrons, but with the word pair in there, it's not the number of pairs, it is actually the number of electrons. Minus 1/2 the number of bonding electrons is the number of bonds, because each bond uses 2 electrons. So whichever of those two equations you want to use, they're essentially the same thing. Let's look at the formal charges for chlorine and iodine in ICl4-. Start with chlorine. So the formal charge is equal to the number of valence electrons, which chlorine has 7 valence electrons. So 7 minus the number of non-bonding electrons. Each chlorine has 3 pairs of non-bonding electrons, so that's 6 electrons. So 7 minus 6, and then it has a single bond to iodine, so minus 1 for one bond, or 1 for half of the 2 electrons that are being shared. So 7 minus 6 minus 1 gives us 0, so the formal charge on chlorine is 0. Next, we're going to look at iodine. Iodine also has 7 valence electrons minus the number of non-bonding electrons is 4. There are 2 lone pairs on the iodine, minus the number of bonds is 4 single bonds, and 7 minus 4 equals -1. So the formal charge on iodine is -1. The sum of the formal charges on all atoms should add up to the overall charge on the structure. So we have 4 zeros, so 0 plus 0 plus 0 plus 0 plus the -1 for the iodine adds up to the negative charge on the entire structure. Formal charges can be used to help predict the molecular structure. So often there's more than one Lewis dot diagram that could potentially be drawn, and we can use formal charges to determine which of them is a more accurate representation of what the actual molecule looks like. The first rule is a molecular structure with all formal charges equaling 0 is preferred. So if we can have formal charges of 0, that's the structure we want. However, if we can't, then we're going to start looking at rules 2 through 4. The arrangement with the smallest non-zero numbers is preferred. So if we can't have all formal charges being 0, we want them to be as close to 0 as we can. 3 says we prefer to have adjacent formal charges of 0 or the opposite sign. So if I have an atom with a formal charge that is negative, next to it I want to have either a 0 or a positive. I don't want to have 2 negative or 2 positive formal charges on atoms that are next to each other. And then the last one, the negative formal charge should be on the most electronegative atom, assuming we actually have to have a negative formal charge. So here I have 3 different structures that could all represent CO2. The first thing we want to do is assign formal charges to everything. Oxygen has 6 valence electrons. Here there are 4 non-bonding electrons on the oxygen and 2 bonds. So 6 minus 4 minus 2 gives me a formal charge of 0 on that oxygen. And this oxygen is identical, so that one is also a formal charge of 0. Carbon has 4 valence electrons, minus no lone pairs, minus 4 bonds. 4 minus 0 minus 4 gives me 0. So this diagram has formal charges where everything is 0, so we know that this is going to be the best structure. Over here, I have oxygen has 6 valence electrons, minus 2 for the 2 non-bonding electrons, minus 3 for the 3 bonds. So 6 minus 2 minus 3, the oxygen has a +1 formal charge. The carbon, 4 valence electrons minus 4 bonds gives me a formal charge of 0. And here oxygen, 6 minus 6 minus 1 gives me a -1 formal charge. Down here, the oxygen, 6 minus 4 for the non-bonding electrons, minus 2 gives me a formal charge of 0. This oxygen, 6 minus 4 for the 4 bonds, has a formal charge of +2. And the carbon, 4 minus 4 for the 4 non-bonding, minus 2 for the 2 bonds, gives me a formal charge of -2. So of these, the best one is definitely the one that has all 0 formal charges. Next we have NCS with a -1 charge, but how is it going to be arranged? Again, we want to assign the formal charges first. Nitrogen has 5 valence electrons, minus 4 for the non-bonding electrons, minus 2 for the bonds. It has a formal charge of -1. The carbon has no non-bonding electrons and 4 bonds, so 4 minus 4 gives me 0. Sulfur has 6 valence electrons, minus 4 for the non-bonding, minus 2 for the bonds, gives me a formal charge of 0. So not everything is 0, but I know that it overall has to have a charge. Here, carbon has 4 valence electrons, minus 4 for the non-bonding electrons, minus 2 for the 2 bonds, gives me a formal charge of 2. Nitrogen is 5 valence electrons, minus 4 bonds, gives me a formal charge of +1. And then the sulfur has 6 valence electrons. There's 4 non-bonding, 2 bonds, so it has a formal charge of 0. Down at the bottom, carbon has 4 valence electrons, minus 4 for the non-bonding electrons, minus 2 for the bonds. The carbon has a -2 formal charge. Sulfur has 6 valence electrons, minus 4 for the bonds. The sulfur is going to have a +2 formal charge. And nitrogen has 5 valence electrons, minus 4 for the non-bonding, minus 2 for the bonds, has a -1 charge. So while we don't have them all equal to 0, and we can't because it has a -1, it's a polyatomic ion, the one that has the formal charges closest to 0 would be the first one up here, N followed by C followed by S. So again, the formal charge is the number of valence electrons minus the number of non-bonding electrons minus the number of bonds. And the structure that has either all 0 formal charges or formal charges that are closest to 0 is going to be the most accurate representation, the preferred structure, and what will most closely resemble reality.